couple of days ago, Andrej Karpathy, Tesla's full self-driving AI lead, posted some really interesting tweets about panoptic segmentation, and I was like, wait, what the f does that mean? For those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $2,300. Check out the link in the description and help the channel at the same time. Hey y'all, it's Dr. Know-It-All. So yeah, I actually did have some sort of a clue about panoptic segmentation, but even I had to go and kind of look it up and think about it a bit. And so I thought that these tweets would actually be really useful for us to talk about today. And it's actually super important to how full self-driving is going to work in the future. Not so much right at the moment, but it's going to be really important for the future. So let's take a look at all of this. I'm going to do some screen sharing, so I'm going to shrink myself down to a little box in the corner, and we're going to talk about what Andrej Karpathy said. Then we're going to look at an article that's written about panoptic segmentation, and then I'm going to show you using NI, natural intelligence, and Photoshop. Thank you to Photoshop. I'm going to show you how to actually build up a segmentation scene so you have a little bit of an understanding of how all of this works. So let's take a look at all that. So you can see here that there's 3 tweets that Andrej Karpathy sent out a couple of days ago. One of 3 says, some panoptic segmentation eye candy from a new project we are bringing up. These are too raw to run in the car, but feed into auto labelers. Collaboration of data labeling at a large 100,000 plus, clean, diverse, multicam plus video data set and engineers who train the models. So we're going to talk about a bunch of that stuff later, but first of all, just note that this says too raw to run in the cars. So this is something that they're working on in-house at Tesla right now. They are not, you're not driving it if you're driving full self-driving or full self-driving beta. So don't worry about it. You're not running this yet, but it is going to be important to the future of full self-driving. So we need to look at exactly what's going on here. Tweet number 2 of 3 says the multicam plus video data, temporal continuity of a slowly moving viewpoint, close collaboration with data sourcing and labeling, and the infinity-sized data set of unlabeled clips dramatically expands creative modeling opportunities on the neural net side. Just as a quick note, it's a little bit of a hyperbole to say infinity-sized data set. What he means is very large data set. It's not infinitely sized, it's just super big. And of course, it's growing as cars keep driving, so effectively it's, quasi-infinite, let's call it that. And then tweet 3 of 3, which is less interesting unless you're interested in getting a job at Tesla, is, it's still early for this task. Help us make these panoptic segmentation predictions perfect and realize the downstream impact. So if you happen to be somebody who already knows what panoptic segmentation is and you're working on that in your AI research, you might want to contact Tesla, because the downstream impact really literally is cars and eventually Tesla bots will be using this as they are full self-driving or walking around. All right, so now let's turn to an article that I think it's Daniel Machea. I don't know exactly how to pronounce his last name, but this is a really excellent article, and I'm going to, of course, link it in the description, so you should definitely check it out. But anyway, it's called What is Panoptic Segmentation and Why Should You Care? So I'm actually going to start at the end of this, and I'm going to talk about the why should you care part, because that's what most people actually care about. It's a TLDW, too long didn't watch thing. So what's important is, for self-driving cars and autonomous vehicles, we need to know what objects are around the vehicle, but we also need to know what surface the vehicle is driving on. And so I'll explain a little bit more about that in just a minute. And also for digital image processing, if you want better smartphone cameras and software that can have pixel-wise comprehension of the people in the image, as well as what comprises the background, will give you that. So just an FYI, I'm shooting this on my iPhone 13 in cinematic mode, and I thought that would be appropriate today. I thought about using some different setups because they're a little bit easier to use, but I wanted to use this specifically because digital image processing for cinema mode uses artificial intelligence to determine the different elements of the scene. And so I have a feeling that they're doing some of this panoptic segmentation themselves using Apple hardware and software. So anyway, I thought that was really cool. We're going to pretty much focus on Tesla, but I thought it was really cool kind of side note that you can use this for image processing and for video stuff as well. And just real quick before I go on with this, one of the big downsides, panoptic segmentation has actually been around for a while, but it's really slow. So one of the deals is, and I'm sure something that Tesla's working on right now, now is how to ramp it up so that you can do it real time. See, it's great if you can use a video sequence and you can use it to train on and everything like that. And if it takes 5 minutes per frame to run, that's fantastic. Or if it's almost in real time on a supercomputer, that's fantastic. That's not going to work in your car or on your phone. So one of the things that I'm sure they're working on is how to make this faster and faster. So anyway, but we need to talk about what the hell panoptic segmentation is before you worry about the rest of that stuff. So let's look at the next slide here. We're going to look at definitions. First of all, pan. Pan means across or every or inclusive. It's a Greek term. And then optic, I'm sure you probably know because that's like your optic nerve. It's vision, essentially. So essentially what they're saying is the term means you're segmenting things, you're breaking things down across an entire visual field. So if you think about a picture, you're breaking down the elements of the scene. So panoptic segmentation sounds all highfalutin, but basically it means you're breaking down the image or video sequence, depending on what you're doing. And of course, for full self-driving, it is a video sequence, but you're breaking that down into its components or constituent parts. So that's what panoptic segmentation actually means, the words. All right, so let's really get into it here. So again, using this article, to really understand what panoptic segmentation is, there's a fair few ingredients we need first, and that is actually true. The simplest way to explain panoptic segmentation is to say it's a combination of instance and semantic segmentation. So the first thing we're going to do is talk about classification, but then also classification segmentation, and then we're going to talk about semantic segmentation. And I have actually done a lot of work on semantics. I actually call it quasi-semantics, and I'll get into that a little bit. But if you're interested, I actually have my thesis document is online if you want to look at that. And it actually deals with what I call quasi-semantics in the visual domain. All right, so first of all is object detection. And that's something that you're probably the most familiar with if you've looked at any kind of AI stuff and of course ImageNet and everything. If you look at this picture of cats, you can see there are 3 cats there. Obviously your NI, your natural intelligence, is telling you that. The important part here for classification is that we need to get category cat. So the next image here kind of combines 2 things. It actually goes into segmentation as well. So the way that neural networks deal with categories is they actually do it in a probabilistic manner. And that's kind of the way your brain does too. If you saw a really fuzzy picture or one where you couldn't quite tell what it was, you might be like, I think that's a cat. I'm not exactly sure, but I think it's a cat. So you'll be like 80% probability it's a cat. So you can see down here, it says classes, cat, dog, bicycle, et cetera, right? If it's the ImageNet thing, it's like a 1,000 categories in ImageNet and millions of images. But anyway, so cats are one of those categories. And so the prediction is 80% positive that this is a cat. So that's what a classification network would do. Now, I want to be really clear about this. Your computer, your phone, your car, whatever is not going, that's a cat in the way that a human being does. We have a whole bunch of information about a cat. And so that's what I call semantics. Semantics is meaning. What I talk about quasi-semantics is that actually the classes internally to the car or whatever would be maybe cat is class 137 in the ImageNet classification thing. So it would be class 137 at 0.8 probability. That doesn't give you it doesn't give the computer any information about cats. Now, Tesla is definitely working on that because one of the things they can do is they can attach class 137 to probabilities, to things like dynamic probabilities of the fact that class 137, which happens to be a cat as humans would think of it, is something that can move on its own. It could dart out into the road, things like that. So you can actually attach meaning to that, but as far as a computer is concerned, it doesn't think of this as a cat like a human would. So it's very important to kind of think about that and to understand that. So again, quasi-semantic. Now, the next step we need to do is we need to segment that. So we've got 3 cats in this picture, and we need to know where each of the 3 cats is. And this is not a classification or a probabilistic issue. This is a regression issue. So if you remember back to like, I don't know, maybe you did it in high school, maybe you did it in college, but like linear regression. Regression actually just means kind of reducing the error, like regress to go backwards. You're reducing the error. If you remember linear regression, right, you get a bunch of data points from your experiment, whatever you're doing, and you're trying to find a line that best fits that. And that's just the minimum amount of error. So here what we've got is we've got boxes instead of lines. So you can see these rectangles around each cat, and you're trying to minimize the error, which is basically you're trying to find a rectangle that fits the cat shape the best possible without missing any pixels in the cat and not getting any pixels in the background as best as you can. So that's essentially linear regression in 2 dimensions as opposed to 1 dimension. It's a square or rectangle instead of a line. So here what you can see from the article is that as opposed to a classification probability, you have a prediction that the X and Y position are 130 and 285, and the length and height, which is the rectangular dimensions, are such and such. So again, that gives you the information you need about where the cat is in the scene, but that directly doesn't tell you that it's a cat, it just segments it. So the two things together, classification and segmentation, start to create semantic segmentation. So then we can start to get to instant segmentation. And what that does is within the bounding box, the bounding box, remember, is very primitive. It's just a rectangle. So what we're going to do is we're going to get like kind of higher level, and we're going to actually segment off the exact pixels. So we're going through the scene pixel by pixel. This is where things get slow. If you're just doing bounding boxes, you can do that fairly quickly. But when you're actually looking for pixel accurate data, then you have to really go through and look at this scene pixel by pixel. And so it can get rather slow. So anyway, what we've done is now we've instanced out everything. So we've got 3 things plus a background. And the 3 things, we don't know what those things are, right? We're just doing instant segmentation. There's no semantic knowledge. It's just saying these things are different from the rest of the scene, and therefore it's an instant segmentation. So each instance as it's segmented creates a binary mask, which is just basically a 1 or a 0. It's 0 or black if it's not part of that instance, and it's white if it is part of that instance. So here you can see the first cat is white against a black background. But again, the computer does not know that that's a cat at this point. It's just like, that's different. That's all it's saying. It doesn't have any understanding of what it is. It just knows it's different from the background. And now we get to semantic segmentation, and that actually does care about that. So again, this is going through pixel by pixel through the scene, and it's going like any place that I see a cat. So we've identified these bounding boxes, and we're like, there's cats inside there, and now it goes through that, and it says, where is the actual cat? And so it's segmenting all of that stuff semantically. But what you'll notice from this image is that all the cats are just like a blob together. They're like, you know, this is cat. Even though there's 3 of them in the scene, it's just going like cat, and then it's going like stuff underneath and then stuff in the background. And by the way, that's actually a technical term. There are things which are countable and there is stuff which is not countable. So stuff like roads or background things like grass and stuff like that is stuff, whereas cats or people or cars or things like that are things. So anyway, that actually is a technical term. It's kind of weird, but that's the way it is. So again, things are countable like the cats, and stuff is not countable. So you can see there's stuff, there's green and there's blue in this image, but then the sort of olive color is the actual cats. But we have not segmented that into the individual cats. We've just grouped it and said these are all collectively cat. So this just gives you a little bit of a verbal confirmation of that. Unlike instant segmentation, we are concerned with all regions, not just the regions we deem to have instances. So you can see the categories are background, pavement, and cat. And again, the computer would be like category 0, category 1, category 2, something like that. It doesn't really understand what they are in a human sense, but it is able to segment out all of these pieces. And now finally we get to panoptic segmentation, which is a combination of instance and semantic segmentation. So remember, the instance segmentation blocked off that what's green in this image, which is the first cat, that it's blocked that off, but it didn't understand what it was. The other thing, semantic segmentation, took all 3 of the cats together and grouped them. And now what we've done is we've broken that all apart. So we've got individual cats. So we're counting the things, and we still have the sort of red and purple, the background elements, the thing that they're sitting on, and the full background. Those are all being segmented out. And now you can start to see how this could be useful for full self-driving. As you can see here, we've got a background element, we've got a pavement element, and we've got cat 0, cat 1, and cat 2. So what we have is we have all of the different elements in the scene and a car. I know this is not a scene that a car would drive on. I'll show you that in just a second. But you can see where now a car could identify the background, which is unimportant, the pavement, which would be what it might be driving on, and then obstacles, which would be the cats. So you can see how this starts to actually become important. And the big advantage of this right now, what I understand is that they're using bounding boxes. They don't really show this anymore, but up until a couple of versions ago, they would actually show bounding boxes around objects in the scene. So that would show the car and everything. And that's great, and it's pretty fast, but the problem with that is that it's not exact. And what they're looking for is to get more exact, right? So if you got a bounding box around a car, you don't know exactly how, well, let's just say like a garbage can. Let's say you're driving down the road and there's a garbage can here. If you've got a bounding box around it, you can avoid it, but you may not be able to get as close as you think you could to it. So if you're really, really trying to be accurate on the road, and again, cars need to do that because they need to be within a few centimeters of being accurate, you need to get better than bounding boxes. Essentially, that's what it is. And garbage cans are relatively rectangular, so that's not so bad. But let's say it's something like a tree branch that's sticking out that you might hit with the car, right? So the tree branch is sticking into the road. You need to identify that as stuff, but you also need to identify it as something that you need to miss, and you can't just draw a giant rectangle around it because the rectangle might include the whole tree, and then you have to go to the other side of the road to get around it. So in order to get more accuracy and to drive better around this, like a human being would do, you need to be able to identify, okay, the branch is sticking here, and here's all the elements in the scene that have to do with that, and I can just go around it just like that. And of course, the other piece of this, as Andrej said, is they're doing this with video, not just with still frame images. So that actually makes a really big difference too. But first, let's talk about images just a little bit more. I'm going to use a picture of my dogs in a driveway just to sort of break this all down. So we've got a picture of dogs in a driveway. Instinctively, you can segment this scene, I would assume, together. But what I'm going to do here is I'm going to turn off the background. You'll see there's a little bit of stuff that'll pop up. And then what I will do is I'll start turning off layers. So I've kind of broken this all down. So you can see I'm removing all the pieces. And okay, so now we've got like our first thing is the driveway, right? And we can attach a color to that just to make it visually evident. But essentially, you know, again, using NI, I just did this myself, but a computer would do this. It would actually look at this and it would say, that is the driveway. That's something that my car can drive on. That's cool. Then it can go like, okay, so here's background. And all of that stuff is unimportant. The background is unimportant because it's not stuff that my car is going to interact with. On the other hand, the road, which I'll color a little bit of a light green, you can see up in the top corner up here, just to flick it on and off so you can see a little bit, it's in the background. But that is also something I can drive on. I can certainly drive on the road as well, and I intend to later on. And then I have a mailbox. And the reason that's segmented out slightly differently is because maybe the mailbox sticks out. This particular mailbox doesn't, but maybe that mailbox actually sticks out. And again, there it is up in the background. Kind of a little bit of a bluish teal color, I guess. Anyway, but that could stick out into the road. Like the mailbox could actually stick out into the road a little bit. So you need to deal with that as a car. And then of course, we've got my doggy Diesel, and we'll color him in a sort of dark blue color. And then we've got my doggy Lily, and we'll color her in a purple color. So now we've got the entire scene mapped out. You can see we've got our background, which is stuff we can ignore, which is kind of the yellowish sort of color. We've got a driveway, which is a surface we can drive on. So we've segmented that out. So that's good. We've got two obstacles, which are two dogs. We've got and also remember, because they're colored differently, they're separate instances. So they're not just collectively dog, but each individual one is a dog, which means the computer can deal with each one. So let's say that Diesel stood where he was, but Lily moved out of the way. That means that you could actually drive the car around. And because of the fact that you're able to see both of them as separate objects, you can maneuver around each one individually. And then, of course, we've got the road and the mailbox. The road, of course, we can drive on later on, and the mailbox is something that we need to avoid as we go out towards the road with our car. All right, so that finally brings us back to Andrej Karpathy's tweets again, and now we can make some sense of this. So panoptic segmentation, we know what that is. We just looked at that. And this is eye candy. So if you look down at the bottom part of this, you can actually see, and maybe the next one, yeah, this may be more evident from the second image, but you can see that the road surface is kind of given I don't know, it's more or less an asphalt color, but you've got these sort of light blue colors around all of the cars. And then you've got, I think it's a motorcyclist behind him, maybe somebody on a scooter, but you can see that they're kind of a brownish color. And then of course the background is given sort of a fade out color so that you can tell it's not that important. And the lights also, of course, it needs to know what the lights are so it doesn't go running into things. But anyway, let's see if this other one, yes. And then you can see a human being that's sort of colored in a reddish color. I think that it looks like the brownish color here for the moped person and for the human being that's walking and for these people that are walking, that would be a VRU or vulnerable road user. The bluish color is for cars. The faded out part is for background. I guess it looks like the sky might actually be its own individual thing. And then the road and the edge of road. So we've got all of the segmentation that's going on here. So anyway, as Andrej Karpathy says, they're too raw to run in the car, which means they probably are still making errors, but also they are probably a little bit on the slow side. Who knows exactly how fast they are. But essentially what he's talking about here is that they're able to do this to feed into auto labelers. So the deal is, even though they're not using it on the road right now, and they're probably not using it for official training just yet because it's not quite accurate enough, they're working on feeding this into auto labelers. And so think about this. This means that you can segment this scene into all the pieces, identify each individual one, label that thing, and then go ahead and put it into the data set that the neural networks can train on. So even if they can't do this in real time in your car, it could be hugely valuable, because if they can train where if the car itself can just do the basic segmentation, then the training can actually deal with like all of the kinematics, like are the cars moving? What are they doing? How do they interact with the scene? How do they interact with your car? Where is the surface? All of that kind of stuff is hugely important. They currently have 100,000 plus video. I think it sounds like it's video, not just still frames, but they have 100,000 plus of this, and it's also all 8 cameras at once and not just, a single camera at once. So it's an 8 camera video sequence. They've got 100,000 of these that are labeled. They're clean. Apparently people have been checking them. Jeez, what a job. I applaud people who are doing labeling at Tesla, because that seems like an incredibly difficult and thankless task. But anyway, thank you. I'm thanking you for that, because I know how difficult it is. Also diverse, that means that they've got lots of different things. I'm sure as I drive around, it's collecting stuff from where I live. People in the Bay Area, obviously people in New York, I assume other countries as well, even though they're not working on that actively right at the moment, but they're collecting all of this stuff. And of course, it's video, not just still images. So that's actually super important. And these people who are doing the labeling and the people who are doing the auto labeling are collaborating with the engineers who are working on the neural network training. So that's the collaboration, and that's what this tweet actually means. And again, just to touch on his tweet number 2, multicam plus video data. So again, all 8 cameras stitched into one, and temporal continuity of a slowly moving viewpoint. So this is actually important too. We're not just talking about segmenting an individual scene, but as the car moves, of course, every single frame, if it's doing 30 frames a second or 60 frames a second, every one of those frames is being segmented also. And I think what he's talking about, the slowly moving viewpoint, is really important, because what that means is, and even if the car is doing 70 miles an hour or 120 or whatever kilometers an hour, it's still slowly moving effectively, right? If you're doing 60 frames a second, you're not moving that far between each frame. So what you can do with that slowly moving viewpoint is you can cheat. You can use the last frame to figure out what the next frame is going to look like, and the next frame, and the next frame, and the next frame. So that's something that's probably very, very important. And again, close collaboration of sourcing and labeling, and the infinity size data set, which again, I said is not infinity size, but every time anybody drives anywhere using full self-driving or not, it's collecting all of this data. So they've got literal billions and billions of miles, and each of those miles has lots and lots and lots of frames. So they're collecting a ton of data. So it's not infinity size, but it's really, really big. So again, quasi or effective infinity size. Of course, the infinity size is only unlabeled clips. So what they need to do is they need to get this panoptic segmentation up to commercial scale so that they can just suck in all of this stuff, have the computer automatically label it, and the poor people who are doing all the human labeling, you could actually sit back and relax a little bit, Operation Vacation, I guess. But anyway, the computer can do all of this labeling, and once it's labeled, it can then push it into the training set. And if you can get this working properly and super accurately, it means that you really do have an infinite size data set, a quasi-infinite size data set. And finally, as Andrej says, this expands the creative modeling opportunities on the neural network side. So that means they can do more interesting things with their neural networks if they have better data sets. All right, thank you for coming along with me on this super geeky ride. I hope you appreciate it. I really, really got into this. I think it's really cool what they're doing. Creating a video-based panoptic segmentation system that's good enough that they can just turn it loose on their massive data set will be absolutely huge. I think that they probably are hoping that they can get this running and fully up to steam by the time Dojo gets running, because this seems like something that is going to create such a massive amount of data that even their current supercomputer might, choke on it. But anyway, they can introduce things a piece at a time. But I would imagine they're thinking if they can get Dojo up and running along with this auto labeling system at the same time, then they're going to be able to make, even though they've been making massive progress, and I've done videos on that, of course, but even though they're making massive progress at this point, they can just jump way, way ahead. So, we're talking about they could do a very, very fast 10x in improvement in full self-driving. And right now, again, it's sort of like a student driver. It drives pretty well. It's not perfect in all situations, but just imagine if they can 10x that. They're suddenly going to be as good as or better than the best drivers in the world, and that's amazing. And that's why this all matters. All right, I hope you enjoyed this video and found it fun and informative and a little bit mind-blowing. If you did, please do like it, because that's how other people find it on YouTube, speaking of algorithms. And of course, consider subscribing for more of this type of content. As always, a huge shout out to my patrons on Patreon. Thank you all so much for all of your help, all of your support, the conversations we've had. I do have an announcement coming up about Patreon. I've literally been so busy with end of semester stuff and all of this other stuff that I haven't had a chance to quite put it together yet, but it's coming soon. So anyway, stay tuned for all of that. In the meantime, thank you all so much for everybody who is a patron. And if you want to join the club, definitely check out the link in the description. And if you're interested in some awesome merch, check out the link in the description. We've got the Tesla Bot t-shirt, which is super popular these days. Don't mess with Tesla. Lots of other t-shirts, tumblers, mugs, etc. So check out the link in the description and help the channel out. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $2,300. Check out the link in the description and help the channel at the same time. Thank you. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a solar roof, a Powerwall, or anything on Amazon helps out the channel. And as always, feel free to ask me questions in the comments or at my email address, which is drknowitallknows@gmail.com. Till next time, bye-bye.